Okay, today we're going to be talking about solving radical equations, and here are the examples used in this video. Remember that if you are looking for something specific, you can scrub through until you find it, and this is in the correct order. So let's go ahead and get started. So a radical equation is simply an equation with at least one unknown under a radical, I should say. Oh, line break. Okay, so a radical equation is simply an equation, let's put a little more room there, is simply an equation with at least one unknown, and by unknown we mean variable, under a radical. So, an example of a radical equation would be something like this. Square root of x plus 1 equals 2. Okay, so to solve equations like this, we want to rearrange it so that there's no radical. So we're doing that based on this principle. If x equals y, then x to the power of n equals y to the power of n. So if x equals y, then x to the power of n equals y to the power of n. So let's start out first with square roots, because square roots are easier to deal with. For square roots, okay, I'm going to go ahead and write this down. For square roots, get the radical by itself, then square both sides of the equation, then you'll have a solvable equation. I'm going to have to put a line break in there. Okay, after square, okay, let's put a little bit more space in between these two things too. Okay, so for square roots, you want to get the radical by itself through, algebraic manipulation. Then you square both sides of the equation. Then you'll have a solvable equation. So first of all, let's talk about what do I mean by get the radical by itself. Well, let's take a look up here at this example. In this case, the radical is already by itself because you have it. It's on the left side of the equation, the left side of the equal sign. There's nothing else here. If this had been like let's see if I can draw this. Feel free to make fun of my bad mouse writing. It's kind of hard to write with a mouse. So if this had been x square root of x plus 1 plus 3, man, I better not do this too often. Okay, so oh, that looks terrible. So square root of x plus 1 plus 3 equals 2. This is a case where you don't have it by itself yet, so you're going to have to subtract 3 from both sides. But in this example, we have the radical is already by itself. There's nothing else on the left side of the equation. So let's go ahead and solve this example right here. In this case, it's since we already have it by itself, we first go ahead and square both sides of the equation. So we have square root of x plus 1, I'm just rewriting it for now, equals 2. So square root of x plus 1 equals 2. So we want to square both sides. So, because remember from this principle up here, if x equals y, and here we have x and y, then x to the power of n equals y to the power of n. So because this is true, we can take the square of both sides. We can rewrite this as the square root of x plus 1 squared equals 2 squared. So now we have well, let's just keep moving. I'll go ahead and you'll see exactly how this works out. Let's go ahead and clear that. So, what is the square root of x plus 1 squared? Well, it's just going to be x plus 1. So that's equal to x plus 1. Oops, not equal to x equals 1, sorry. So that's just going to be x plus 1 equals, and what's this over here? 2 squared, well, that's just 4. So, x plus 1 equals 4. So now we can subtract 1 from both sides, and we'll get that x equals 3. Okay, so, but there's one more piece to the end of this. Let's go ahead and scroll down a little bit, and I'll go ahead and show you something else. Let's move this a little bit. Okay, so there's one more piece to this. After we solve it, we always check the solution. After we solve, we always check the solution, and the reason why is we'll get into the theory behind it, why exactly that it happens that way. But for now, I'll just say that just because you have something that looks like it's going to work out, you may put it back into the original equation, and you'll find out that it doesn't work. So that means we need to see. Sometimes we'll get more than one solution, and we want to check both of them. Sometimes you'll find that just one of those solutions works. So, for now, let's go ahead and go on to another example. Let's go to 2 more examples. Then I'll get kind of, once you get the feel of it, I'll get a step-by-step thing going on. So we'll have, for another example, if we have square root of x plus 2 minus 3 equals 4. Okay, square root of x plus 2 minus 3 equals 4. Okay, so here we have a case where the radical is not yet by itself because we have this 3 here. So what we want to do is you want to add 3 to both sides. And so we'll have add 3. I'm hoping that maybe one day my mouse writing will get better, but until then, well, that's a long way off. So let's go ahead and clear that off. So we add 3 to both sides, and we'll get square root of x plus 2 equals 7. So square root of x plus 2 equals 7. I just added 3 to both sides, and negative 3 plus 3 is 0, 4 plus 3 is 7. So now we're in a situation where we can square both sides of these equations. So let's go ahead and I'm going to skip this stage for now. Actually, no, not for the next example. I'll skip a step because hopefully by then you'll understand it well enough. But for now, I'll go ahead and write this out. So we have the square root of x plus 2 squared. Square root of x plus 2 squared equals 7 squared. Okay, so the square root of x plus 2 squared, that's just going to be x plus 2. And then 7 squared, that's just going to be 49. And now we can subtract 2 from both sides to get x equals 47. Now, now that I just realized I'm not exactly sure that I checked the previous example. In fact, I'm pretty sure we didn't. I'll go back to that, but right now I want to finish this one up. So, because after we solve, we always and forever check the solution. So let's go ahead and check this one right now. So if we have x equals 47, I'm tempted to do this, you know what, and I am going to do it. I'm going to at least try it. So we have 47 plus 2 all under the square root minus 3. Now when we're checking this, we want to make sure that this entire thing equals 4. So, because we want the left side to match the right side. So what's 47 plus 2? Well, that's just going to be 49, so that's... oh, that was bad. Let's go ahead and erase that. So 47 plus 2 is going to equal 49. And we still have the minus 3. And the square root of 49 is going to be 7 minus 3. And 7 minus 3 is going to equal 4. And lo and behold, 4 is what we're looking for. So since the left side equals the right side, we know that we did it right. So let's go ahead and clear that. And now, that means that this is a correct solution. So this is a... wow, that looks so bad. I'm just going to give it up on that. So bottom line is this is a solution. Okay, so now let's go back up because I don't want to leave this hanging. I can go ahead and tell you now that this does work out, but let's go ahead and do it. So we have square root, in fact you could probably see it already, of 3 plus 1 is equal to the square root of 4, which is equal to 2. And just like before, it works out the same way. We have 2 on both sides. So that means that we checked it. So that means two things. That means, one, we did it right. That means also that it's a valid solution. Okay, so now let's go on to another example of the same type. And after that, I'm going to want to get into the theory behind this. So let's say we have example. We have that the square root of 5x minus 4 equals 6. So square root of 5x minus 4 equals 6. So as just like before, we want to square both sides of the equation. But I'm going to go ahead and skip showing, like, I'm going to skip this step, and I'm just going to go straight into that 5x minus 4 equals 36. Okay, so all I did was I squared both sides of the equation. So remember that, and I want to repeat this, the reason why this is true is since we have this rule, the principle that if x equals y, then x to the power of n equals y to the power of n. So that means if square root of 5 minus 4 equals 6, then the square root of 5x minus 4 squared, I guess I will go ahead and do it. I'll just do it this way. Hopefully one day this will be not so bad. So square root of 5x squared equals 6 squared. So now we have 5x minus 4 equals 36. This is a problem that we can work with. It's not too hard. So let's go ahead and add 4 to both sides because we want to get this 5x by itself, then we'll get the x by itself. So adding 4 to both sides will give us that 5x equals 40. Then we want to divide both sides by 5, and we'll get that we'll get that x equals 8. So now let's go ahead and check this, and let's go ahead and I'm going to go ahead and just do it on the next line. That way I'll spare you my bad mouse writing. So check. So say we have the square root of 5x. Oh wait a minute, I didn't. Square root of 5x. Not 5x. It's 5, 8 minus 4. Okay, so 5, 8 minus 4. That's going to be equal to the square root of 40 minus 4. Do you see that? It's just 5 times 8. That's all I did. And 40 minus 4 is going to equal 36. So this whole thing is equal to the square root of 36. And square root of 36 is equal to 6. And then 6 is what we wanted the right side to be. That means that two things: we did it right, and it's a valid solution. Okay, so now I want to go into the theory behind, more of the theory about why it works. Remember, so let's say the theory behind it. Now the bottom line is, whoops, went down too low. The bottom line is that you know how to do it, but it's still good to understand exactly why it works, and it's not too complicated, but it's still good to go ahead and go over the square root of x squared. Yeah, the square root of x squared is the same thing as x. This is a rule we've talked about in previous sections, but there's another concept. So say and aside from that, we have this next rule, that if square root of x equals y, then x equals y squared. If square root of x equals y, then x equals y squared. There is a qualification to this, though, as long as a solution exists. Because, like I said, we always want to check the solutions, because there's a chance that there might be something wrong. And let me tell you exactly when you'll find that a solution is invalid. Now, again, this is getting into the theory behind it, but and you won't need to know this to actually do the work. The easiest way to find if a solution exists is if you find a solution and that solution does not work. But you will see that a solution that you find does not work if it results in this side being 0. So if your y, not 0, I'm sorry, negative. If your y is negative, see, there is no, in the real number system, there is no square root that's going to equal a negative number. So that means that if you have a negative number here, you're not going to have a solution. I mean, for that particular solution will not work, so what I mean. And so if you have square root of x equals -2, well, there is no real number such that works. So now let's go into a step-by-step thing to try to go like a list to go through. And this is not really necessary. It's just, oops, I need to put a little line break. It's just that you can use this to get started, but once you get the hang of it, you won't need to refer to this list at all. Get the radical by itself. Raise both sides of the equation to the root of the radical. Now that sounds more complicated than it is. Basically, all I'm saying there is that, like, if it's a square root, you square both sides. If it's a cube root, you cube both sides, etc. And I'm going to put in a line break. Okay, so we've already done this before. It's you raise both sides of the equation to the root of the radical. So if it's a square root, you square both sides. If it's a cube root, you cube both sides, like that. So remember, let's see if I go ahead and draw this. We had x squared, sorry, square root of x plus, what was that first example? Plus 1 equals 2. This step here, the second step, this is only saying square both sides. But it's also saying, what if it's not a square root? What if it's a third root? So let's say we have a cube root of x plus 1 equals 2. Well, then we don't square both sides, we cube both sides, because we'll have to cube it to get rid of the radical. Okay, so let's get rid of that messy writing. And that's the second step. Third step is solve the equation. Because once we're done with the second step, the third step will be pretty easy, because we'll now have an equation that's easier to work with. And then the fourth one is check the answer. And that is important. Don't forget to check your answer, because it's important. Okay, so now let's go ahead and do another example, and you'll see here in this next example where checking your answer becomes very important. That's a hint that we're going to get an invalid solution. So let's say, for example, we have 12 plus square root of 4x plus 5 equals 7. Okay, so we want to go ahead and get this radical by itself, so we can subtract both sides by 12. So that means we're going to have square root of 4x plus 5 is equal to negative 5. And then we will go ahead and square both sides of the equation, and we'll get 4x plus 5 is equal to 25, because 25 squared, negative 5 squared is going to give you 25. And then 4x equals 20. So 4x equals 20. And then we divide both sides by 4, and we'll get that x equals 5. So now let's check the answer. So I'm going to go ahead and do it. I'm going to go ahead and do it over here. Let's see if I can get some practice in on getting my. Well, that's readable. So that's not too terrible. So check. We have 12 plus square root of 4 times 5 plus 5. And all I did was I put 5 in for x, because that's our solution. And I'm going to see if that comes out as 7. If it doesn't, then that means something went wrong. So 4 times 5, this is going to be 20 plus 5. Then we still have the plus 12 out here. So then this 20 plus 5 is going to give us 25, square root of 25, plus 12. And then this square root of 25 is going to be 12 plus 5. And 12 plus 5 is going to give us 17. And we're looking for 7. I don't think I'm going to do that anymore, at least not for a while. It looks terrible. So we're looking for 7, and 17 is not 7. That means that there is that this is not a valid solution. So that means there is no solution. Okay, let's clear that stuff away. So that means that somewhere along the line we had that a square root equals a negative number. And look, here it is. So that means that whenever you have a square root equals a negative number, now I'm almost reluctant to even say that, because I think it might confuse you further, but the easiest way to find out if there's no solution is to go ahead and solve and put it back into the original equation and see if there is no solution, if that results in something different. Because if you get a solution that doesn't work, if you plug it in and this does not equal 7, that means one of two things: either you did it wrong, and you made some algebra mistake somewhere, or there's no solution. And that's why I kind of want to show you the theory behind this, because that might make it a little bit more clear as to why there might be no solution. Because in this case, well, what square root will give you -5? Well, nothing will, at least not in the real numbers. So that means that there's no solution based on this problem here. Okay, so now let's go on to another example. So we have the square root of y plus 10 equals y minus 2. Okay, square root of y plus 10 equals y minus 2. So let's go ahead and square both sides. We'll get that y plus 10. Okay, so what's y minus 2? So let's go ahead and do that. I'm going to do it below underneath, just because like below this dash, I'm going to go ahead and do it, then I'm going to erase it. y minus 2 quantity squared. Okay, so we're going to be foiling this out, so we'll get let's go ahead and rewrite this as y minus 2 times y minus 2. And I know this is kind of a review, but I thought this might be a good time to go ahead and do it. So we're going to do, this term is going to give us y squared, and this term will give us minus 2y. Don't forget the minus, because you have a minus here and a plus here. And then this term will give you a minus 2y. Oops, not 4y. Minus 2y. And then this term, this term will get you a plus 4. Now, of course, you could also see that this is a perfect square, but whatever way you want to do it. So this, to simplify this a little bit further, is going to equal y squared minus 4y plus 4. So that means that this is what we want this side of the equation to be. So let's go ahead and write that in. X plus 10 equals y squared minus 4y plus 4. Okay, so let's go ahead and clear that stuff off. That was just scratch work. And now we want to go ahead and combine like terms. So we can subtract a y from both sides. And let's go ahead and move the y over here. So we'll have that 10 equals y squared minus 5y plus 4. So all I did was I subtracted y from both sides. And now we want to subtract 10 from both sides, and these are the like terms, so we'll have that 0 equals y squared minus 5y minus 6. And if it's all the same to you, I'm going to go ahead and flip this around. I'm going to write this as equals 0, if for no other reason than I'm gotten so used to, and you may be too, so used to seeing the 0 on the right side, so I like to go ahead and keep the, I like it that way, so I want to keep the 0 on the right side and all our terms over here. So we can factor this. So this will be factored down to y minus 6 times y plus 1. And of course still equals 0. And let's go ahead and clear off all the stuff up there. So that means that y equals 6 or y equals -1. Y equals 6 or y equals -1 based on these two right here. Okay, so now let's go ahead and check it. So let's start with 6. And I'm going to go ahead and do it lower. I mean, like below. I mean, like instead of writing it off to the side, I'm going to do it here. So let's check. I'm going to go ahead and I want to underline this, just because this stuff's really important. We don't want to forget it. So we want to check this, and we'll see that the square root of 6 plus 10. Okay, so all I did here was I put 6 in for y. I put 6 in for y on the left side of the equation. And just after I'm done with this, I'm going to put 6 in for y on this side of the equation. So for now, square root of 6 plus 10 equals square root of 16, which is equal to 4. And now we want to try the right side. We have 6 in for y. And so this was the left. I'm going to go ahead and write this down. This is the left side. Left side will give us this. And let's go ahead and scroll down a little bit. So just so we have a little bit more room. So now we're putting y equals 6 in for the right side. So we have 6 minus 2. And of course we can see that that's equal to 4. So they match. This 4 matches this 4, so check mark. Oh, that is not a good check mark. Check mark. So we know that 6 is a solution. So I'll go ahead and write that down separately. So we know that 6 is a solution. So that means we have at least one solution. But we want to go ahead and check the negative 1 too. So let's go ahead and try that out. So I'm going to go ahead and I'm not going to delete this stuff, but I'm going to move it below. So because I don't want it in the way, but I also don't want it I don't want to scroll down below it. So let's go ahead and try negative 1 now. So we're going to put negative 1 in for y. So we'll try the square root of square root of negative 1 plus 10. Square root of negative 1 plus 10. I'm going to go ahead and write that. This is the left side. And we're checking, and I forgot to put that too. So we're checking the left side. So square root of negative 1 plus 10, that's going to equal the square root of 9, which is going to equal 3. Okay, so the left side is equal to 3. Now let's try the right side. So we'll have negative 1 minus 2. Okay, and that's equal to negative 3. Okay, so now we have a problem, because this right here is not equal to... Okay, let me clear that out because that was deprecated. So this right here is not equal to this. So that means that negative 1 is not a solution. So let's cross it out. Okay, that's excessive. So y equals negative 1 is not going to be a solution. So I'm going to go ahead and cross it out this way. So y equals negative 1, not a solution. So let's go ahead and move this stuff back up. And we know that. So y equals negative 1 is not a solution. And right below that. That's the previous solution checking that we had before. So our final answer to this specific problem, I know it took a while, but our final answer is going to be that y equals 6. It took a while this time, but whenever you actually are working on it, it won't take as long as you might think. So let's do one more example for this. It's going to be something a little bit different from what we've done so far, because so far we've only done square roots, but there's nothing stopping us from having the same types of problems with cube roots. Now, most of the homework is going to be over square roots, but there are at least a couple problems, I think, that involve cube roots. So we have cube root of 4x minus 1. And that plus 4 is going to equal 7. So cube root of 4x minus 1 plus 4 equals 7. So let's go ahead and subtract 4 from both sides. So this will give us that the cube root of 4x minus 1 equals 3. Cube root of 4x minus 1 equals 3. I just subtracted 4 from both sides. And now we have the radical by itself, so we can take both sides to the power of 3. So remember the rule. I said I wouldn't do it, but I'm going to go ahead and do it anyway. So the nth root of x all to the power of n equals x. So we're using that principle here. So let's go ahead and clear that away. And on the next line, we'll have that 4x minus 1 equals 3 cubed, which will be 3 times 3 is 9, 9 times 3 is 27. So we have 4x minus 1 equals 27. So let's go ahead and add 1 to both sides. So we'll have 4x equals 28. Sorry to say 29, but it's 28. Now we divide both sides by 4, and we'll get that x equals 7. Now let's check. Does 7 work? Well, let's put it in and see. So we have cube root of 4, 7 minus 1. Cube root of 4 times 7 minus 1. I just put 7 in for x, 7 in for x. And we only need to check the left side because the right side is a constant. So we just need the left side to equal 7. And of course this plus, not plus 1, plus 4. And so then we'll go ahead and try this out. 4 times 7 is, oops, I didn't mean to scroll down. 4 times 7 is going to be 28. 28, so we have the cube root of 28 minus 1, still plus 4. And then we're going to have, that's going to be the cube root of 27 plus 4. And what's the cube root of 27? That's just going to be 3. I'm going to go ahead, I'm going to go ahead and move to the right instead of going down because I want to be able to keep all of this on the screen. So 27, square root of 27 is going to equal 3, so it's 3 plus 4 equals 3 plus 4. 3 plus 4 equals 7. So 7 is the right side of the equation. So since they're equal, that means we have that x equals 7 is a valid solution. So x equals 7 is a solution. Technically speaking, your answer doesn't actually have to have words like this. You could just say x equals 7. But the reason why I'm saying that is just so I can understand, it could be understood that this is a solution. Because if you say that something is a solution when it has no solution, then you actually got the problem wrong. So that concludes this particular video. That was section 8.5, and that is actually the last section from chapter 8. So I will see you in chapter 9.